Welcome back, students, to our Chemistry 1510 Chapter 4 video notes. We're going to talk about two types of chemical reactions and look in more detail about the first kind, which are called metathesis reactions. So if you've taken chemistry before, you've probably heard of metathesis reactions with some different words. You probably heard them called double replacement or maybe double displacement. So these are reactions that fall under the umbrella of metathesis reactions. Metathesis is just the more grown-up way to say it. So inside metathesis reactions, you can have precipitate reactions, acid-base, which is also called neutralization, and technically you can have one more that we call gas-forming reactions. And then we're going to save oxidation reduction reactions in more detail for later, but if you've taken chemistry before, you have probably seen these called redox reactions. So again, we're going to come back to that one later. Let's focus right now on metathesis reactions. So when you look at metathesis reactions, there are three ways that you are going to have a reaction take place. So one of these three things has to happen in order for a reaction to occur. So let's go through and kind of figure out how to predict the products. So this is going to be a key component for exam 2. I'm going to give you something that looks like this. Right? I'm going to give you the reactants. Then you're going to tell me what the products were. You're going to balance the chemical equation. You're going to tell me the equation's state. It is going to take a lot more brain power than you originally anticipate. So first, let's look at the ions that we have available. So for the first compound, sodium carbonate, that contains a sodium and it contains a carbonate. Then the second compound contains calcium ion and chloride ion. You might notice that I purposefully left out these balancing subscripts, right? And when I say balancing, they're balancing the charge between the ions present to make sure that there's a net neutral charge for that compound. I'm purposefully leaving those off. So I just want to list what ions are available. Then what's going to happen is we're going to switch partners. So your sodium and your calcium are your two positive ions, and your sodium's going to take the place of the calcium, and the calcium's going to take the place of the sodium. So when that happens, now you're going to have calcium and carbonate together, and then you're going to have sodium and chlorine together. So now that we've switched partners, these two are going to come together to form one compound, and these two are going to come together to form a compound. So now we have to go back to nomenclature land, where we learned how to name things. And we have to make sure that we're writing the correct chemical formulas so that the charges balance. So notice how calcium has a 2+, carbonate has a 2-. So this is going to come together in a 1-to-1 ratio. So this is going to be CaCO3, calcium carbonate. Then notice how sodium and chloride, sodium has a +1, chloride has a 1-. Those cancel in a 1-to-1 ratio. So sodium chloride is NaCl. Oh, and don't forget, you don't like my uppercase or my lowercase l, so I'll change that to L like that. So now that we have correct chemical compounds, what we need to do is go back and balance the equation. So that's down here. Step 4, balance the chemical equation. So when we balance that chemical equation, there's enough space for us to rewrite this down here. We had sodium carbonate plus calcium chloride. And when that reacted, we formed calcium carbonate and sodium chloride. So now if we look at this, you're going to notice that there are an unequal number of sodiums and an unequal number of chlorines on both sides. So notice here we got 2 sodiums, but only 1 over here. We got 2 chlorides and only 1 over here. So the way to solve this is to put a 2 in front of the sodium chloride, and then we have everything equaling out. Remember, you can either add the numerical value of 1 in here, or if you don't write anything, I'm going to assume you mean 1. So these two were given as aqueous, and we also want to add the equations of state. That means we're going to add solid, liquid, gas, and aqueous. So in order to figure this out, what the equations of state are for the calcium carbonate and the sodium chloride, let's look at the little flow chart that's below. So when we look at this flow chart, it asks, how do you know if the products are solid, liquid, gas, aqueous? Oh, that's a great question. So let's start with, is your product water? Okay, let's do this flow chart with calcium carbonate. Is your product water? No, calcium carbonate's not water, so we go this way. Is it a gas? Here are the list of possible gases. CO2, SO2, NH3, and H2S. No, calcium carbonate is not one of those. Then we come here. That means it's either solid or aqueous, so we have to use the solubility rules. So when we use the solubility rules, carbonates tend to form insoluble compounds. Calcium is not an exception, so that is going to be a solid. So let's go through the flow chart with sodium chloride. Is sodium chloride water? No. Is sodium chloride a gas? No, because it's not CO2, SO2, NH3, or H2S. Okay, that means that we need to use our solubility rules. And sodium is an alkali metal, and alkali metals are always soluble with no exceptions. So this is going to be aqueous. So do you see why I'm giving you the solubility rules? Because right now it's just too much. So we have one more thing to look at. This idea of the gases and looking at how we know what the possible gases are. So if we scroll down really quick, there's this section that shows kind of what to look for when we see gases. So if you have H2S, that's a gas. If you have NH3, that's a gas. These ones are trickier because these are the 2 different ways that you could make carbonic acid. And carbonic acid is going to automatically decompose. Just bam, turns into H2O and CO2. And CO2 is definitely a gas. So how are you going to remember that this automatically decomposes? Well, when you see carbonic acid, that kind of reminds you maybe of carbonation. And so carbonation is really carbonic acid that is under pressure in your soft drinks. And as soon as you open that soft drink, you hear the psss, which is the gas being released. And over time, your carbonic acid turns into CO2 and water, and then all that CO2 goes away from your soda, and now your pop is flat and you're a sad chemistry student. The same thing is going to happen here with H2SO3. The only difference, right, is see how over here you had a carbon, over here you have a sulfur, and you make SO2 gas instead of CO2 gas. If you have to choose one to memorize the carbonic acid. That is much more likely to show up on exams and your ACS standardized final exam. So even though this might look simple at first glance, we're going to spend a whole lot of time in class practicing these because it involves quite a bit of brain power. So that's it for this video. We will come back and look at things like titrations and dilutions in our next video, which will be for next, not this next class, but the class thereafter. So thank you so much for your attention. This is Katoni signing out.